Malaysia is a country rich in natural products and abundant in resources. Since the year 2000, its government has actively promoted a series of economic development projects, many of which involve construction and infrastructure. RSEA Engineering Agency extended a hand of friendship as early as 1983, entering this promising and rapidly developing engineering market, and has since contributed its efforts to the advancement of public infrastructure for the Malaysian people. The first project undertaken by RSEA Engineering Agency in Malaysia was the Gurun Expressway project, a north-south highway spanning a total length of 928 kilometers. RSEA Engineering Agency was responsible for the section between Alor Setter and Gurun. As the route had to traverse swampy terrain, construction proved to be extremely challenging. The completion of another project, the new Klang Valley Expressway to the west of Kuala Lumpur, opened up a new economic backbone for the region. Leading to the development of the kind of free trade zone in Ipoh and the Sungai Piah industrial zone in Kedah. These zones attracted numerous domestic manufacturers to invest and establish factories, serving as successful examples of infrastructure-driven development. In 1987, RSEA Engineering Agency won the lowest bid for a major power station project in Malaysia. The Sungai Piah Hydroelectric project, located in the mountainous region approximately 60 kilometers northeast of Ipoh in Perak, Malaysia, was a massive and formidable undertaking. The project site was located in an undeveloped rainforest at an elevation of 800 meters. To promote economic development in Perak State, the Malaysian government specifically chose the Piah River Basin for the construction of the power station. The planned catchment area covered 364 square kilometers. The entire project was primarily divided into two construction sections, the upstream and downstream segments. The upstream section included an upper power station, a low-pressure tunnel, steel liner tunnel, and access tunnels totaling 8,000 meters in length, along with 2 vertical shafts and 3 intake structures. The downstream section included a low-pressure tunnel, plant access tunnels, a lower power station, steel liner tunnels beneath the plant, and a free-flow tail-race tunnel, totaling 16,000 meters in length. It also featured 4 intake structures and 6 vertical shafts. Other construction work included more than 1.6 million cubic meters of surface excavation, over 300,000 cubic meters of backfilling, 66 kilometers of road improvement, 11 kilometers of new road construction, and 5 bridges. The basic design was to collect water from mountain streams and tributaries, channeling it to the power station through diversion tunnels, and using the elevation drop and abundant inflow to generate electricity. The project officially began on April 10, 1987. In the early stage of construction, a secondary camp was established in the upstream section and a main camp in the downstream section. Construction equipment was sourced from Saudi Arabia, Gurun, and Taiwan. RSEA Engineering Agency applied flexible deployment strategies to make the most efficient use of these resources. As the project area spanned a radius of 95 kilometers, all work sites were located in remote, undeveloped jungle. Survey crews had to traverse mountains and ridges on a daily basis, and the work was extremely demanding. Construction roads served as the main arteries for the project, with a total road length of approximately 91 kilometers within the work area. All construction had to be carried out in steep mountainous terrain and dense rainforest, making the work extremely difficult. Among the total length, 35 kilometers were shared with logging trucks operated by forestry agencies, which not only carried heavy loads and caused significant damage, but also made road maintenance even more challenging. RSEA Engineering Agency therefore established a dedicated road maintenance team to carry out repair and upkeep work, ensuring smooth transportation and supply access. The total length of tunnels in the Sungai Piah Hydroelectric project reached 23 kilometers, making it the most challenging part of the entire construction. The upstream section was divided into 3 work phases, and the downstream section into 5 work phases, all of which were successively launched. First, RSEA Engineering Agency introduced the downstream section of the construction. 4 work phases were carried out simultaneously in the downstream section, including a 17-kilometer main tunnel, access tunnels, a free-flow tailrace tunnel, and 1 lower power station. The tunnels were constructed in 3 different diameters: 6.2 meters, 3.42 meters, and 3.72 meters. At the initial stage of construction, work began at the Dindap Adit and 2 working faces extending upstream and downstream toward Beltek Adit, the access tunnel to the lower power station, the upstream vertical pressure shaft tunnel, and the Piah Kechil Adit. Furthermore, earthwork excavation at the upper power station site was also progressing at full speed. In addition to on-site construction work, the Sungai Piah Construction Office continuously researched and improved personnel training and the transfer of construction techniques. This project adopted the new Austrian tunneling method for tunnel excavation. Construction personnel first conducted surveying and staking out, followed by drilling blast holes using a jumbo drill, then loading explosives and wiring them for detonation. To overcome the challenges of tunnel excavation, the construction team carefully developed various blasting techniques to adapt to different rock formations, avoid over-excavation, and reduce construction costs. After blasting, ventilation was carried out before mucking operations began. In the early stages of tunnel entry, due to the narrow and extended cross-section of the tunnel, RSEA Engineering Agency had to rely on small auxiliary equipment to remove the muck in order to maintain construction progress. However, both excavation and mucking operations were difficult and affected the project schedule. To address this issue, RSEA Engineering Agency introduced a new type of rail-mounted mucking loader. At the front of the machine were 2 crab claw-like scooping arms, followed by a conveyor belt. When the machine was activated, the scooping arms alternated continuously, pushing soil and rock onto the conveyor system. The conveyor belt then quickly transported the muck backward, unloading it into the muck car stationed behind the machine. The machine had a mucking capacity of 30 cubic meters per hour. After screening, the excavated material could be reused as graded material for constructing temporary access roads. In the downstream headrace tunnel, from a 200-meter adit, excavation extended 4 kilometers both upstream and downstream. Since there was only one access point, RSEA Engineering Agency had to carry out meticulous planning and calculations to prevent the 2 working faces from interfering with each other and affecting construction progress. Owing to the use of the smooth blasting method, the tunnel face exhibited a neat and visually appealing result. The rock quality in the downstream headrace tunnel was excellent, allowing for the immediate commencement of the invert concrete work after surface cleaning. Meanwhile, 4 working faces in the upstream section were deployed simultaneously. These included the 8-kilometer-long main tunnel, access tunnels, vertical shafts, and 1 open-air powerhouse. The tunnel diameters were of 2 different specifications, 2.42 meters and 2.72 meters. The upstream low-pressure tunnel passed through a fault zone with extremely weak rock. Due to the small cross-sectional area, excavation machinery could not be used, therefore, manual ring-cut excavation was adopted. Before the track was fully laid, construction workers relied on small auxiliary equipment to remove excavated material in order to maintain the construction schedule. When the track was fully laid, pneumatic RS-55 mucking machines were used in the upstream low-pressure and steel liner tunnels, in combination with small 2 cubic meter muck cars for debris removal, achieving a mucking capacity of 6 cubic meters per hour. Powered by electricity, the RS-55 mucking machine offers several advantages, including zero air pollution, compact size, and ease of operation. The upstream low-pressure tunnel passed through a sand-bearing stratum, resulting in core loss. Through the tireless repair efforts of the construction crew, the tunnel was stabilized and reinforced. Before proceeding with the tunnel concrete lining, the rock surface had to be thoroughly cleaned to prevent poor bonding between the concrete lining and the rock surface after completion. RSEA Engineering Agency used a movable steel formwork system to cast the concrete lining. Each steel formwork was 11.8 meters long and could pour up to 9 meters in one operation. The entire Piah Power pressure tunnel was constructed using 3 different lining types: reinforced concrete, plain concrete, and concrete-filled steel tubes. 8 hours after casting, the movable steel formwork could be removed from the tunnel. Through such repeated operations, the tunnel lining was gradually completed. Since the pressure tunnel must withstand water flow pressure, in addition to the concrete lining, high-pressure grouting was also carried out to fill the gaps between the rock layers. There are a total of 10 vertical shafts in the tunnel. Among them, one each of the long shafts measures 240 meters, 340 meters, and 343 meters, constructed using the latest reaming method. The 6 short shafts, ranging from 30 to 50 meters in depth, were constructed using the traditional drill and blast method, with muck removal carried out by rail-mounted bucket hoisting. Due to the abundant groundwater in the upstream pressure shaft, it was only after multiple grouting and waterproofing operations by RSEA Engineering Agency that the severe seepage issue was finally overcome. There are a total of 9 check dams, distributed throughout the entire route, and all are miniature-scale small dams. The intake structure at the site is under full-scale construction, with workers tying rebar in preparation for the subsequent concrete pouring. Due to terrain constraints, the concrete placement is extremely difficult. In addition to using concrete pumps, a bucket hoisting method is also employed. Among them, the Tour Check Dam, which collects discharge water from the upstream power station and channels it into the downstream headrace tunnel, is the largest of the check dams. The Sungai Piah Hydroelectric project includes 2 power stations in total, one of which, a lower power station, belongs to the downstream construction section. The lower power station's access tunnel was excavated by RSEA Engineering Agency. Due to excessively loose geological conditions in certain sections of the tunnel, inverted arch concrete was immediately poured after excavation to maintain the stability of the tunnel. RSEA Engineering Agency used a dual-boom, rubber-tired, electric jumbo drill to bore blast holes. The power station access tunnel was designed with a total excavation length of 1,030 meters, with a downward gradient of 12%, and was constructed using the new Austrian tunneling method. However, during tunnel excavation, a large amount of groundwater was encountered, gushing out from the tunnel face as if a dam had burst. Due to the heavy inflow, the tunnel was severely flooded. Under extremely difficult circumstances, several high-head large-capacity pumps were urgently deployed. Due to the steep downward slope of the power station access tunnel, pumping out water was extremely difficult. After careful planning by the construction team and continuous day and night pumping, the heavy groundwater inflow was eventually overcome, and the excavation of the power station access tunnel was completed. The power station access tunnel enters the lower power station, then a side tunnel is opened leading to the top of the plant. From the top, the roof pilot heading above the power station is expanded, and excavation of the lower power station begins using a top-down bench blasting method. Muck removal was carried out using loaders and trenchers, in coordination with dump trucks. After entering the lower power station, a natural underground stalactite cave was discovered on the side of the plant. As it concerned the safety of the power station and the tail race, RSEA Engineering Agency carried out rock surface protection and implemented necessary protective measures within the natural cave. The lower power station is located within the mountain, designed as a plant measuring 64 meters in length, 16 meters in width, and 25 meters in height, housing 2 generators. After the lower power station excavation was completed, concrete casting operations commenced. Due to spatial and topographical constraints, RSEA Engineering Agency adopted various methods: concrete pump truck casting, electric pump casting, and chute casting. Despite the numerous challenges, the concrete casting work was eventually completed. While the concrete was being cast in the lower power station, it was necessary to coordinate with foreign contractors for the installation of the generator units, and RSEA Engineering Agency was responsible for installing the pressure pipelines. Although the Sungai Piah Lower Power Station project was not massive in scale, it was extremely challenging, and the construction team overcame numerous hardships to complete it. The other power station in the Sungai Piah Hydroelectric project, located at the upstream section, was an upper power station. This upstream upper power station was constructed using a high-slope excavation method. While excavation was carried out, vegetation was planted simultaneously to protect the stability of the slopes. The total excavation area of the plant measured 40 meters in length and 40 meters in width, with an average excavation depth of 5.3 meters and a total earthwork volume of 8,000 cubic meters. The foundation elevation was at 534 meters above sea level. After completing the site leveling, RSEA Engineering Agency proceeded with the excavation work, while simultaneously constructing the drainage facilities for the power station. Despite the challenging conditions, a concrete bridge was built to provide access to the upper power station. The upper power station on the upstream section of the Sungai Piah Power Station is an open-air facility. The first floor is constructed with reinforced concrete, while the second floor adopts a steel structure. The plant measures 17 meters in height, 27 meters in width, and 36 meters in length. RSEA Engineering Agency carried out the foundation concrete pouring work. Upon completion of the foundation, the main structural concrete for the power station was cast. After the first floor concrete structure was completed, the installation of the turbine crane was handed over to the client. The structural requirements for the upper power station were extremely precise. During the concrete placement, RSEA Engineering Agency had to coordinate with the foreign contractor responsible for the generator units to embed components and carry out the civil works accordingly. The construction of the upper power station, after completing the tail race drainage structure, the foundation excavation, and the placement of unreinforced concrete for the foundation, then proceeded to the structural concrete placement phase for the turbine hall, cable conduits, and other related structures. This upper power station is located near the confluence of the Tur River and the Piah River. Its foundation concrete is 2 meters thick and is designed to accommodate 2 generators. The upstream upper power station and the downstream lower power station of the Sungai Piah Hydroelectric project are approximately 10 kilometers apart. The designed power generation capacity of the upstream power station is 13,000 kilowatts, while that of the downstream power station is 51,000 kilowatts, bringing the total installed capacity to 64,000 kilowatts. Upon completion, the generated electricity will be integrated into Malaysia's national grid, supplying the entire power demand of the Ipoh area in Perak State, thus making a significant contribution to the economic development of the Malaysian people. This hydroelectric project was located in a remote area, making construction extremely challenging. In addition to facing tropical monsoon seasons, workers also had to contend with threats from tigers, elephants, and wild bees. These RSEA Engineering Agency's staff working at overseas construction sites have endured hardship and fought with perseverance. Many of the hardships and joys in their work and daily life were transformed into a strong fighting spirit and loyal cohesion through their faithful embodiment of RSEA Engineering Agency's 4 core management principles. Through their relentless efforts and strategic growth, RSEA Engineering Agency has expanded and established itself as a key player in Malaysia's engineering market.